Hello, everybody. So I'm here to speak to you about a new project I'm working on, which is called Project Builder, which is trying to provide a tool to support a mechanism that I call continuous packaging, that I will try to explain in the next slides. Just to introduce myself, I'm working at HP. I've been involved in software engineering since a certain number of years and also Unix systems. And I'm developing two main open source projects. So the one which is presented today called Project Builder, and another one which is Mondo Rescue, which is a disaster recovery solution for Linux. And I'm also packaging software from Mandriva, a bit for Fedora, trying to be useful. So what is the problem I had, and one of the problems I'm not alone to have, in fact, is that you have Linux users who try to use software, and most of the time they're much more interested by using packages because it's much easier for them to download a package and to install it on their distribution. Most of the people do not know how to build the software. It's just they barely know how to use it, so they don't know how to build it. So most of the people would prefer to use deb packages, RPM packages, Gen 2 packages, or whatever you have on your underlying operating system. It's convenient because also it respects the convention of your distribution, so it puts the files in the right place. It's uninstalled cleanly, so when you uninstall the package, you know that you have removed everything which was brought by the package. So it's easy for users, it's easy for administrators as well, because it remains in compliance with the way they're installing the distribution. They can put it in a yum repository, apt-get repository, and get channels, or however you call them, of packages and pull packages from that channel. So it's a smooth integration. It reduces administration time. I mean, I did, as everybody, I began with Slackware distribution, and I did my share of configure, make install stuff, and it's funny for a couple of years, but after that you want to use the software more than compile it. So it's much easier to use packages. Certain number of people still like to use tarballs and compile their own packages, either for optimization performances, because their distribution does not provide a packaging system, because they want to use the latest and greatest version of the software, and the software does not provide any package for them, so they want to use that. And very few people are, in fact, using the configuration management system provided by the project because they don't know how to do it, they don't know where it is, it's complicated to extract data from it, to rebuild from it. Each project has its own way of dealing with that. So you don't have a lot of people and users testing the current state of development of the software. When we go on the developer mindset, they don't really care about packages. What is their interest is they are grouped around a configuration management system, could be whatever they have, Subversion, Git, Mercurial, Bazaar, and they want to produce software under a format which is generally a tar file that they upload on a website or an FTP server to give the availability of the software to their users. And you don't really know how they are working, what type of software engineering tools they are trying to put in place to improve the quality of the software. Are you using auto tools, for example, to make the software independent from the underlying platform? Do they have an installation procedure, a clean one which integrates correctly with the package system? Are they using any quality tools, software engineering tools? Are they afraid about distribution picking their application and doing stuff they don't want with it? That's their environment. And then you have a third category of people who are packagers, sleeping in the room, for example. And those people are already a strange beast because they take the result of the developers. They work with sometimes a configuration management system, most of the time today, and they want to produce packages for their preferred distribution. But sometimes those people do not exist, so you don't have the software package for your distribution. They are missing. Sometimes they are not on time. They have a life, they have children, they do something else, they have their own projects, whatever. So they lag behind the version that exists. They could lag behind the main version, but they could lag behind in terms of intermediate version. And sometimes they don't want to package all the time, all the night, so they just release stable version, but they don't want to release intermediate versions so that people can test them. So it's very difficult to have, except for very famous projects, you don't have generally the possibility to test intermediate versions for applications. And they also have some tools they could use to improve the quality of their production. So RPM lint for RPM systems, Lintian for Debian packages. But sometimes they use it, sometimes they don't use it. Some distribution have guidelines, some other not. So again, the quality of the resulting packages is not ensured. So what is the solution? So it's a wrong header. I should write what is a solution. I mean, that's my view on the subject. As packaging should be a project concern. It should not be just a concern from people making daily packages for their preferred distribution, and especially for smaller projects. It's for me a mandatory step, as all the other steps in the development of the project, such as testing, the installation procedure should be part of it, sometimes it's not. People should be really concerned inside the project about the fact that their software will and should end in a distribution and should be packaged in a distribution. So they should make it easy for people to package the distribution. My opinion is that they should do that probably themselves, or at least helping a lot to make it possible. But they should make it as easy as possible. And my mantra personally is package early, package always. Not even often, but always. I'm fed up installing tar files on the system. Each time I do that, I regret it later on, because I have to clean stuff manually. I don't have my dependency tree anymore. I don't know to which file belongs to what package. I cannot query the database to have information on it. So it's always a nightmare. So rather than doing that, I really prefer to package the application before using it, even if I do a test of an application. It takes a bit of time, but it's really much more interesting at the end. So my personal approach is to say packaging should be your only way to deliver software to your users. And users could be internal users, external users, depending on where you're working and for whom you're working. It really, I mean, it's not a dream, because that's the way I'm working now on the project I'm working on. So it's really so that you can really achieve, it's possible. There is a overhead. I don't want to say there is no overhead. There is, of course, an overhead, but it's really minimal. It's not much longer to produce a package or to produce a tar file that you will give to your users, but it brings much more information in terms of metadata and coherency. There is a maximum benefit, because if you use tools to produce your packages that will be consistent, that will be reproducible, so we'll get all the benefits of having packages to query the database, etc. It's easy to integrate your packages in your distribution. So if you're upstream and you care about it, you will make it easy for distribution to pick your project and integrate it. And so you will have more coverage, so you will have more users, more test cases, etc. So for me, in fact, if you think about packaging, you could think of it as a marketing activity for your project. You make it easy for people to use your software. You communicate better, you have more testers, you have more users, more return, and your project is attracting more people, and it's much more easy for everybody to deal with it. So for me, the solution is trying to adopt a continuous packaging approach, which means generally you don't, if you look at a classical V-cycle approach, I don't want to say it's a better one, but that's one example. You design your software, you have the user requirements, functional specification, design specification, and you start to code. And generally, you start just here because you don't care about that. And you produce code in your software configuration management system. And at that point, at the unit tests level, you can already produce packages instead of producing tarballs that you give to the unit test team, if it exists, or to yourself on another platform if you want to test on separate platforms. But instead of using tarballs at that level, you can already produce packages. And I put here 3 lines because I'm working on a project in which we try to address multiple operating systems. So not only differences supporting different Linux distributions, but also supporting other type of operating systems, just as a proof of validation. So I'm working with As an example, now Solaris, because that's what my customers are interested in parallel to Linux, because we want to be able to deliver packages for multiple type of operating systems, but sharing the sources on one side for the project, but also trying to share the metadata around the package management. When you create a package, you have a certain number of informations which are similar, whatever the package format you have. So similar between Debian, between RPM, between Solaris. You have a name, you have a version, you have a release tag, you have a header line, you have a description, and even some people try to join to share the description and the header to translate them all together. I think it's a very good idea. But you can share a lot of metadata if you are producing your software between all the package management system. And even part of the build of your software is the same on different platforms. So you could also be able to group that information and not duplicate information. That's part of my points here is to avoid duplication of information, maintaining it only in one place to produce all those packages. And those packages can make their life themselves along the return cycle. So you pass some of them to unit tests, they give you feedback, you fix them, then you pass an integration test, your packages, validation up to your customer. And the good stuff is that the package you're producing here could be exactly the same as the one you will deliver to your end customer. So my personal answer to that problem analysis is I'm a system administrator on some of the system I'm managing, so I just want to use packages. I don't want to mess up my system by installing something else. And I have a deployment server, so I just want to put my packages in my deployment server and benefit from that. I'm also developing open source projects, so I want to make tests easy for me. So when I install a test version of my package, I don't want to have multiple versions and multiple directories, having the risk of interdependency between themselves, making the test failing for not good reasons. So I don't want to screw up my system, and I prefer to install a package, remove a package each time I want to make tests on my own application. I'm also packaging software for distribution, so I want to make it easy and to have a tool for me to help me produce package much more easy for the distribution I'm dealing with. And of course, I'm the only developer of the project on which I'm working mostly. We are very few. So I'm also the marketing department of my project. So producing packages for me a way to say to people, hey, my project is great, it's easy to use for you. Just grab the package, install it very easily in your package management system, and you have access to my application. I have a background of software engineering, so I don't want to duplicate anything as much as possible if you can avoid it. So including the metadata around package management. And I found no real tool to do what I wanted to do at that time, so I started writing my own. In fact, I started as everybody writing a set of scripts to support my first project, and finding out that some other projects, especially I had colleagues in HP wanting to package some other applications, and we thought it could be useful to reuse my scripts, but my scripts were not adaptable easily, so I rewrote the project completely from scratch in order to be able to make it project independent, in fact, as much as possible. So there are a certain number of goals around the development, and the goal to support your continuous packaging approach is to be agnostic, because you don't know what people want to use in terms of tooling to develop their project. So it should be configuration management system agnostic. It can support flat files if you have flat files, but as I said, we are in the 21st century, so now it's time to use Subversion, CVS, Mercurial, Git, Bazaar, whatever you want. And Project Builder is currently supporting those 5 configuration management systems, but you may add easily more if you need. It should also be agnostic in the way it's working for generating packages. So it should be able to generate RPM depths, eBuild, Slackware packages. Currently, I'm building packages for my projects for something like more than 60 different distributions. So distribution being something like Fedora version 7 for i386. So this is one distribution, one tuple, one combination of a distribution. It supports also the repositories linked to those distributions. So it creates indexes for YAM, for URPMI, for APT. It also supports Solaris packaging since the last version, and it's now, it has always been, but it's much more easy to prove it. It's easy to adapt it to new package management system appearing. So I have requests working for HP to have support for the package format of HPUX that I could very easily add to the system without any problem. One of my issue personally was also it should be build environment agnostic. So I want to build packages locally on my laptop or on my build machine. And I want to be able also to cross-build for other systems, which I don't have, which I'm not running locally. And there are multiple ways to do that. So either you're using Shroot, and you have some tools, depending on the distribution, to generate those Shroots. So rinse, mog for mainly RPM systems, Dead Bootstrap for Debian-based systems that you can use to generate the Shroot and build into those Shroots. Another way for me, which was more convenient, in my opinion, was to use a virtual machine. So the tool is able to pre-build the Shroot or pre-build the virtual machine for you, and then use it as a way to build the packages which are seen as native packages for that build environment, be it a virtual machine or a virtual environment shrooted. So supported right now QEMU KVM. It's not libvirt aware up to now, so it's part of the evolution. I still need to work on to support other type of virtualization mechanism more easily. And one of the goal was to have no impact on the original project. So you don't want to put more pressure on upstream. You want to be able to package them. So if upstream want to package, they can use the tool to do it, and it's very nice for that. That's one of the goals. But if you want to package for another upstream project and you don't want to make any impact on them, you have your own configuration management system separated in which you keep all the metadata you need to build your packages, and you can do that for that project without themselves not knowing their package in any way. And you can just take the tar file with the MD5 sum of the original project and use that as an input to your tool, and it will package it from it completely. So what we've done recently is we have used the tool to show to some of our customers how to realize a multi-platform development cycle as easy as possible. I don't pretend it's an easy way and easy stuff to do. So it's mostly interesting for people developing in C, C++, people developing in Java or other type of applications may have different problems to solve. The idea is to say you have a lot of code in common and you produce that code. You can produce it for multiple operating systems in parallel by sharing a lot of common source code, having only a minimal set of differences between, so for example here it's Solaris on Spark, Solaris on x86, and Linux on x86. And the idea is to say generally people are concerned in the development up to that point, so producing executables. So we have tools inside HP to help them trying to share as much as possible the common code and to isolate in small libraries what is different. And we provide some tools to help them have the missing system calls in the environment compared to for example, a Solaris environment. But the idea is to say we can go one step further, and adding Project Builder in the loop, we can go to produce the executables, and then from those executables, data file, man pages, configuration files, or what is needed for a project to work, you can package them using the native package system and produce local packages just from a single repository containing all those information plus the metadata information. And it will be clear in the next slide. So in addition of what I've described up to now, there are some goodies coming with the tool. I have a set of existing virtual machines. So currently on one of my disks at work, I have 120 gigabytes of virtual machines ready for me to be called to build packages for all those distributions that I've built during time. So since Fedora 5, since Mandriva 10.1, since Debian 3, etc., etc. So I keep all my virtual machines because one problem that distributions are not so good to deal with is that distributions are looking at the future. So they want to produce packages for their current distribution and the future distributions. They are not very concerned by the past, but customers are. Customers are often running older distributions than what people are developing on, and they need, and you have projects such as backport initiatives for various distributions, they need to have packages also for their running systems, which are sometimes late in in the evolution of the distribution itself. So they have to be able to produce packages for an old Debian, old stable, for a former Mandriva, Fedora, or whatever distribution, RHEL 4. Who still is using, I mean, I don't know if you're working for customers or yourself, are you still using RHEL 4 in your environment? 1, 2, 3 customers, 4? Okay, not a lot. Personally, the customers in front of which I'm working with, they have a lot of old stuff like that. And so having for them an easy way to produce packages, not only for the latest and greatest version of the distribution, but also for older version, is something which is quite important. So I have my VMs to do that myself, and the tool is helping you, if you give it the ISO image, to recreate the build environment for whatever older version that you want to package for. There is a certain number of macro available inside the system, and you can define your own macro in order to share the metadata. So for example, I define one macro for the header of the package, which is a line describing what the package does. That macro is stored in a single configuration file, and every package I made is referring to that macro. So I don't have to update the macro in all my packages when I change the header line or when I change the description, etc., etc. So I try to concentrate in a single place the metadata and to reuse them through that macro mechanism across the packages I use. And I was very pleased with that, because when I added Solaris support to the tool, I didn't have to change anything in my tool or in my description of existing packages. I just created the template for the new Solaris package, referring the macros that were already existing, and the package was just right out of the box. So it's quite interesting. When you create a new project, the tool will create a skeleton for you, providing you with templates for an RPM type of build, a DEB type of build, a Gen 2 type of build, and a Solaris Now type of build. So it gives you a skeleton. Of course, it does not, if you have seen the OpenSUSE build system demonstrations, they have nice GUI, so I don't have the GUI. And they have some automatic way of creating the build part of the package. I don't deal with that. It's up to you to deal with the build part, but the rest can be helped a lot. And it provides some goodies for me, which I find useful for me. I don't know if it's useful for other people, but I mentioned them anyway. I do the delivery of my packages on my FTP server directly through SSH, and I rebuild the indexes on the FTP server. So as soon as I publish a new version of my project, people doing YAML update will get the new version on their server if they use my repository as their main repository to get packages. Again, when I do a new version, I have a way to make announcement to the mailing list automatically, printing the list of new packages that have been made, etc., etc. I use snapshot features of VM and virtual environments if possible. I'm working on integrating tests, because as I have the infrastructure now, it's very easy. If you launch a virtual machine, for example, to build the software, it's as easy to launch a virtual machine and to do something else, such as testing that the package is installing correctly and that it works the way you want. So you can add a certain number of test scripts to the tool. It supports patches if you are not an upstream project, so that you can integrate the patches into the packages you are making. It launches automatically linting and RPM lint at the end. So if you want to check the coherency of your packages, it's easy for you. Don't want to pass too much time on that. So this is a big picture at the end. You have the users, the developers who are producing the projects through their configuration management system, and then provide one tar file for you. And you have the packagers, which generally are providing metadata around the project and create other files. So Project Builder, what it does, it instantiates all the metadata and creates another tar file containing multiple build files for all the distributions supported. So it creates one spec file per RPM distribution that you need. It creates one Debian directory containing all the files needed for Debian per Debian or Ubuntu type of distribution. It creates one ebuild file for Gentoo, etc., etc. And then you can build locally and generate your packages on your running machine, or you can send those two tar files into your VM, and the VM is also using the tool and generates the packages the same way. And at the end, you can push all that to the FTP server and have it delivered to your community. Here is a list of commands. So I don't know how it's working during the event. There is a possibility, so the slide set is hosted on the project Subversion, so you can have access to it, and I suppose that the presentation will be available. So I will not necessarily detail all those commands one by one. I'm not sure it's interesting for you. You will have access to the presentation, so you can look at it and ask me questions if you're interested with it. Globally, you have commands to take from the configuration management system information, create the tar files, from the tar files, create the packages, send them to the SSH, send them through building through a VM or a virtual environment, etc., etc. So certain number of, so it's a command line interface tool. It's like an SVN or a Mercurial type of syntax. You have PBs and the command and then the parameters. I find it easy to use, but of course I wrote it. So, so if you look back at building software, so I have customers currently, big ones that I cannot necessarily name, who are very interested by migrating from Solaris to Linux. And I say, way. But how to do that? And how to, and they have another problem is that their own customers, so they're producing software for end customers. And those end customers, they don't necessarily want to abandon the Solaris platform that they have bought in the past, or Spark platform. So my customers need to maintain in parallel different versions of software during a certain amount of time. And so they need to have the capacity to easily build for multiple targets, reducing the cost as much as possible. Because if they go to Linux, it's because they want to reduce the cost of the underlying platform and of the software subscription contracts, etc. So if they come from old HP, UX, AIX, Solaris to go to Linux, it's because the cost is interesting. So at the end, it should cost less. But if you duplicate the build and the maintenance load on that, they will not gain the money they expect to gain in the process. So their idea is to say, okay, we will have for a certain amount of time to maintain in parallel two development trees, one on our existing platform and one which we are promoting on Linux for the future. But we will have to deal with that in parallel during a certain amount of time. So the developers will still work around the configuration management system, and they will produce roughly, most of the code will be just generic enough to run on whatever Unix systems they want to deal with. And I'm not dealing with something other than Unix type of systems. And they will have to generate some of the files which are different, providing the missing system calls, for example, or stuff like that, which are not compatible between different versions of Unix type of operating systems. And the people on top of the development, the people working on the packaging of the software, they can store in a single database all the metadata around all the packages that those teams have to produce. They will generate their tar files, and the development team will generate their own tar files, which will be in fact the same in that case. And the tar file will contain again all the information for the multiple distributions, and using a build form, so they will probably not use VM as I do, but they will probably rather have a build environment, so dedicated machine to build software. So they will use a build form to produce the packages for the various projects and sub-projects that they want to deal with. And they could have a build form using x86 type of platform running either Linux or Solaris. They could have Spark platform to build for their Spark application. So the tool is, I've worked on the tool since 3 years now. I use the tool regularly every day for my own upstream projects. So I know it's at least working for what I do with it. It's released under the GPL. You can download it. You can test it. I have other colleagues in HP working on it a bit, so begin to receive some feedbacks and some improvements. There are some, I use a lot of VMs myself to build the software, so more tests needs to be done on virtual environments. I have added Deb Bootstrap very recently for my Debian colleagues inside HP, so I'm a Mandriva contributor. I'm much more used to RPM myself, but the tool, the goal of the tool is to be really independent from that. I don't want to create a tool which has a flavor of one distribution. I prefer to make it generic enough and integrate all the tools which are needed. So Deb Bootstrap is not at the same level as what I have for the other distributions. So it's something I need to work on, including rinse and mock. I've made some patches for rinse because it was not able to work correctly. Rinse is nice because rinse is working as well on RPM-based distribution and or Deb-based distribution. So you can, because what is strange in that, the native platform, if you think about that environment, when you're building packages locally, people can build packages on their own distribution, but they could be a large set of different distributions themselves. So the tool needs to run onto different type of distribution very easily. So they can use shroot, which are different from one distribution to another, and shroot mechanism, which are different from one distribution to another. What I need to work on is, and I've seen that also in the one of the previous presentations, is LSB shroot support. Knowing that the LSB shroot that is provided by the Linux Foundation is a bit insufficient in terms of the tools they are providing. So there are a lot of libraries and modules that are not available in the LSB shroot that would need to be added before Project Builder is able to run in the LSB shroot itself, which is not the case with a fully a complete distribution, because even if there is something missing, Project Builder will download what is missing to have it working automatically. I need to work on making it more generic and supporting libvirt and virsh to make the interaction with virtual machine more capable of handling other type of virtualization mechanism. It will add an abstraction layer in the tool for that. We can add other CMS, other virtual machine systems, but as every open source developer, I'm working first for myself. So I put in the tool what is interesting for me. If some other people need something else, I welcome patches, of course. So for example, Bazaar is not yet here. VMware Xen are not tested currently. Need to support more deliveries than just SSH, even if SSH is quite generic enough for me. And people wanting to use build farm, there is a need to look at how to interface that tool with Buildbolt, which is a tool to monitor a build farm. And what is interesting in Buildbolt is a queuing mechanism, which I don't have in Project Builder, and I don't want to mess with that. I prefer to rely on another tool. And Buildbolt is also very interesting in the reporting it provides to you, what has been built, what has been done. It creates web pages dynamically containing information on what you have produced in terms of packages. So this interaction is something I need to work on. Signature support is currently not provided because I had problems with RPM on Debian. It's simpler. On RPM, it does not work correctly with GPG agents, for example, and I want to make it automatically available. So if you don't have the GPG agent running, you don't want to sign every package manually. That's not possible when you build a large set of packages. Documentation is improving, especially since the time I made the slide. I have made an internal lab in HP for my colleagues. So now I have a lab document which describes how to start with a project from scratch, which is available on the website of the project. So it really gives you all the steps to do packaging of your application from nothing up to producing packages for Debian RPM using virtual machines and virtual environments. So Dominic is not here, I think, anymore, but because he had a train to catch. But one of the possibilities, so the tool is written in Perl, and Dominic has written a config module for Perl, which allows you to easily manage configuration management files And one of the problems currently is that I don't have any graphical interface, including to manipulate the configuration files, and I have a certain number of configuration files and items. So config model would be a very good tool to provide help information on how to fill the configuration file content. Some links on it, and I'm done, just on time. Exceptionally. Thank you. I have 1 minute for questions. Great.
Do you have some ways to get feedbacks when a build fails on one of the VMs?
When a build fails, generally you don't get the packages back.
Okay.
So that's a good feedback.
Yeah, because you're not able to know if this package doesn't work on this version of this OS?
Well, generally you will, at least at the first, when I create, for example, Fedora 13 is out tomorrow, or in 2 months, I don't know. I will create my new VM for Fedora 13, I will set it up, and then I will launch my build on Fedora 13. Most of the time it will work just fine because there is no big change between Fedora 12, which is already built for, and Fedora 13. If there are some problems in the build mechanism, then I will look at them and I will have to solve them in my metadata, is a set of the metadata I'm managing. So it could be a problem with a spec file, it could be a dependency which is not managed the same way between all the distribution, etc.
So do you reinstall from scratch your VMs every time you install, you build or install a package?
So the good idea is to use snapshot. So you create your VM at first, you snapshot it the way you have created it, and then you always restart from the snapshot. Project Builder will upload from the main, so it's Fedora 13, they will take the YAM, the package missing for building your package, it's analyzed. So we are looking at build requires and requires lines, and for Debian as well. And we install dynamically the packages which are missing inside the VM or the virtual environment. And then we try to build inside that environment. And at the end, if it's a snapshot, you revert to the original virtual machine that you had, so you're safe.
I have one more.
No problem.
Do you handle security on the VMs? Let's say if a package tries to reach the network or stuff like that, do you cut the network, or you don't really handle that part?
No, I don't really handle that part because for me it's a sort of sandbox. I mean, I'm building myself a VM, so I trust it as much as I trust myself to behave it correctly. So building the package, the tool has been designed for upstream people wanting to package easily for because upstream people generally don't know how to package. So having a tool for them to help them making package more easily and for beta version is very interesting. So they generally know what the application is doing, and there is no good reason to put more security in the build process than in other contexts. I mean, and in any case, in the worst case, if the VM is completely trashed because the package made something, the build steps make something completely ugly inside your VM, you crash the VM, you rebuild one, and you fix your build steps because there is something wrong with your build instruction somewhere. But there is no reason. There is an SSH communication between the host and the guest, the way I'm communicating, and I create a dedicated account inside the VM called PB, and I always build non-root inside the VM. So, okay, so it's quite limited in terms of damages that you can create inside the VM, because you can erase everything owned by your own account, which is not allowed inside the VM. You just have your home directory mainly. So that's the way it's done.
Thank you.